If I add one more zero, there will be one more zero, which is 10 microseconds. Slowly flashing. Yes, it is a less wider. It is a maximum range. I mean maximum frequency. Now I give minimum time delay, meaning maximum frequency will be right now driving this coil. If I add 250, let's say, milliseconds, let's say 25 milliseconds, I think. 25 milliseconds. Upload. This is it, and see what's uploading. We can see it's slow, and we can easily read this message, no signal, which is right now this monitor we are disconnected. And if you can see, I am thinking, why not try with horizontal coil? But I told you I can do more stuff, but I really calculate, I realize it a little bit. Now I remove the horizontal winding. I cannot touch this monitor is on. I remove the horizontal winding from its port, and also connect to the other channel of this l298n motor driver, and also the other l298n other channel also connected pin number digital 3-4, which is I also include the program. I reflash the code just as before, which defines also the 3 or 4 and 5 and 6. 5 and 6 already used. 5 and 6 already used. We now use 3 and 4 for other channel input. That channel output is used to the horizontal winding. Connected to horizontal winding, which winding already connected to a motherboard. In this monitor, so I took out this connector and removed the all wires. Horizontal wire is left channel, vertical winding is right channel output, and both the channel inputs are connected. The right channel input is connected, which is horizontal input. 3, 4, 5, 6. These are outputs, and there's it will also work with single 12-volt battery. Now show that from the screen. Now I modify the tone, just doubling the code, same code with double the statement, only change the pin number and change the function, and also change the time. Delay 1 millisecond and vertical horizontal. I change the setup since it will overheat the motor driver. I try and made the setup, and after I realize it is twice heat, I run only 2 minutes. Now we have 2 motor drivers I use. One motor driver is driving the vertical winding, just as usual my previous part 3 video, and then we can use the extra 1 motor driver, which is right now I put out here. This one here I use a bridge mode configuration, meaning there are dual actually l298n motor drivers. So there are 2 channels, 1 motor net there, 1 motor net there. So I bridge these 2 channels, 2 terminals to that made a 1 terminal, and other 2 channels to that to made a 1 terminal. Since these are no priority, since it will phase shifting or switching with alternative HBD configuration, right? Positive, negative. So I bridge these 2 terminals to that to make a 1 terminal, and other 2 terminals to bridge to 1 terminal. Now this dual bridge motor driver was a single bridge motor driver, HBD driver. Now it is a double the power. Now it's type 4 amps of current, 2 amps per channel. So we have connect 2 channels parallel to make a 1 channel with double amps. And the motor driver VCC, which is 12 volt, is connect this motor driver 12 volt, and this motor driver ground as connect this motor driver ground joined to that. And the motor driver ground, battery ground, as well as arduino ground already connect to that, since I already tell you in my part 3 video. And this arduino VCC is not connected to any one motor driver as well as battery. Battery is 12 volt battery, which connects both the motor driver 12 volt terminal with by consider parallel. These 2 motor 12 volt lines are parallel with this battery, and these 2 motor drivers ground plus battery ground and arduino ground is common. Why? I tell the reason already, since ground is a common for the reference signals. And these motor drivers have 4 channel inputs, 4 outputs. I join 2 outputs to make a 1 output and other 2 outputs to 1 output. So we have 4 inputs. Similarly, I use same 1 output, first 2 inputs as a 1 output, other 2 input used as a 1 output. So there is a 4 outputs regional 4 outputs into 2 outputs and 4 inputs to 4 inputs. So we at first 2 inputs to breadboard. I use the breadboard row. Here we at the first setting pin of the input signal is to one side, one row, setting and third pin to other row. For this motor, horizontal driver, which is a normal horizontal drive line of driving horizontal drive. And we give only 2 signals from arduino. One is drive, first 2 pins, first 2 inputs, and other drive setting 2 inputs, and first 2 outputs are common, and setting 2 outputs are common, which gives to the horizontal winding. And vertical is same. There are 2 input and 2 outputs are used, 2 input and 2 outputs not used. The 2 outputs is directly connected to the vertical winding, and 2 inputs directly connected the 5 and 6 pin, and 3 or 4 go to a breadboard, which is as a breadboard row, which acts like a port extender where we get 2 signals in these positive negative row, and we get 4 outputs which are feeding to this motor driver. 2 are same, and other are 2 are same. So also this motor driver output 2 is common to the other, and other 2 common to the other to make a one output which drive horizontal style. So this configuration known as a bridge mode. If you use before a speaker in a bridge mode, you may know what I talking about. Now those the front of the screen, and this time I will finally to tell I use one battery to drive both motor driver as well as both the toils. Since if you use separate power supply for both the motor driver and toils, and we also need to common the ground because both the motor drivers and Arduino, since Arduino sends signal to the motor driver itself, and these signals reference point or return point or return path known as a ground, which is always common no matter how many boards or how many modules connecting in the DC configuration. I mean common narrative, which is a DC configuration. And you can see it made this type of effects. Okay. Now we can connect this and now see what effects it's made in. Now it changed the variable. right now it's working a 1 millisecond delay. Now if I add a 10 millisecond delay, this time I quickly do, since I added the 2 motor driver, but it will also consume too much power and it overkill my motor driver, and I will do quickly as possible. Otherwise it might be fry my motor driver. And see, change its shape. If I add, let's say, 100 millisecond delay for both the outputs, and now see what's happening. Now 100 millisecond delay from 3, and see what's happening is now it's a simple dot which is moved up and down like slow motion. If we add one more zero, like 1 second, this is the maximum value I put, which why I already tell you in my part 3 video. So you can see it's though like this. If I do little bit like let's retry with 10 again, and though it's a minus 10 afterwards. Now it's made our light this way. Now we do, I mean microsecond range, like 0.1, also 0.1 here, 0.1, I think I put double 1, and let's see the result. See, it's look like this. It is a very weird shape. If I had more the 10 microseconds, which is the last minimum value I can put there. Otherwise it is over killed. We can see now once pause, I made a little bit changes and then continue the video.